is that actually like not so much. So really the topic of this talk is how can AI and machine learning developers become more customer focused. And I think, as you could see from the title, A/B testing, in my opinion, A/B testing can help in this. Okay, so the outline of what I'm going to talk about is I'll give an introduction to A/B testing. I'll give examples of real experiments. I'll talk about why A/B test AI systems, what are the benefits more concretely. And then I will also share 5 lessons and pitfalls from actually applying A/B testing to AI. Because there are some specifics and some gotchas that if you actually start doing it, that will help you to avoid some of the errors that I made in the past and that others made. Okay, so let me just give you a little bit of a preview of some of the elements of the talks there. So let me start with a story. This is a true story that happened in Bing in the beginning of 2012. An engineer at Bing had an idea, and the idea was very simple. He wanted to change the way that ad titles are displayed in search results. And what he wanted to do is to take the first sentence from the description and just move it into the titles. So make the title a little more prominent. So that was the idea. But this was, one of the hundreds of ideas on the table, and compared to many other ideas, it seemed like, man, nothing special. Some kind of a small tweak, who knows, maybe interesting, maybe not. So the idea was put into the backlog, and it stayed there for 1 month, then another month, and 1 more, and 1 more, and essentially, after 6 months, it became clear to the engineer, this idea is never going to make it. There are many features that ranked above it. It's not going to happen. But he thought, it's trivial to implement. It's only about like half a day of work. So he just implemented it in his free time and started an A/B test, which I'll talk about later, what it is. And immediately after he started the test, an alert fired. And the alert said that something is wrong. We are making too much money. This can't be true. And 9 out of 10, maybe actually like 99 out of 100 times when this happens, there is actually a bug and it's not true. But in that case, there was no bug. And that simple idea increased Bing revenue by 12% at that time, over $100 million a year, and it didn't really hurt the user experience either. So the lesson from the story is that we as humans are actually very bad at assessing the value of ideas. Like, this was probably the best revenue generating idea in Bing's history, and no one could really see it. And the opposite is also true, that often we think that we have a great idea, but in reality, it turns out to be not that good. So the takeaway is that we shouldn't really trust our intuition when we want to evaluate ideas and decide whether some idea is good or bad. We should really use data. And the best way to use data to evaluate the value of ideas is A/B testing. So this is a quick introduction to what an A/B test is. We have users coming into our experiment. We randomly assign them, every user, into one of the 2 groups, either the treatment group, which has a new feature X, so that new feature X is our idea that we want to test, or they get a control group, which is just the standard system, standard website or app that we are testing. And then we let the users use our product for some time. We collect the data, and at the end, we compare metrics and determine the winner. And if everything was done correctly, and at the end we see a statistically significant difference in the metrics, then with this kind of design, we can be pretty sure that this difference in metrics is actually caused by the new feature X. So A/B testing allows us to establish that causal relationship between the change and the metric movement. Okay, so there are many different examples of A/B tests. It's used in many different industries. For example, at Outreach, we A/B test different versions of email templates. At Bing, we used to A/B test changes to web pages. In Windows, where I used to work, we used to A/B test some of the features. Like this is a search box at the bottom left corner of Windows screen. And we were trying to decide what text we should put there so that people search more, and many other types of changes in software we can A/B test. Now, the question is, should we A/B test our machine learning models? And why should we A/B test our machine learning models? And I talk about it more in the talk, but really I think the essence of it is that A/B testing allows us to establish this virtuous circle, where we can really measure end user impact of our machine learning models, not just accuracy or ROC curves, but actually our users really having better experience because of what we did. And then in return, what we get is that types of learnings and insights about the behavior of our model that it's very hard, pretty much impossible really to obtain with the standard evaluation, offline evaluation methods. All right, and so if you are convinced that it's a good idea to do A/B testing for machine learning models, then the next question that comes is, how do I actually do it? And there is now standard vendors on the market which can actually help you really technically implement A/B testing. But then when you try to run A/B tests on machine learning models, there are actually some important aspects which you need to keep in mind. And this, in my mind, are the top 5 issues that you need to be aware of. The fact that AI versus no AI tests are difficult, and you need to really think of how you do it carefully. That you need to ensure the equal learning opportunity, equal amount of data flowing into the different variants in your A/B tests. You need to be able to zero in on a specific scenario that your machine learning model is tackling, as opposed to just all the scenarios. You need to be able to detect side effects. Perhaps you are improving one aspect of your machine learning model and just accidentally affected something else. And then you also want to be able to measure not just the final output, but really all of the different steps, because often production machine learning pipeline is not just one model, it's many models stringed together, and you want to know the impact of each step on the final result. So that's what I'm going to talk about in more detail at the conference. So that's all. That's what I wanted to say, a quick preview.
And I'm the founder and CEO of a healthcare startup. It's called Neura Health, and it's based out of Philadelphia. So just a little bit of my background. So at Neura Health, it's a 7-month-old startup company. Currently, I'm working on building data pipelines and machine learning pipelines for our products. I'm also defining the product roadmap, looking into operations, hiring, regulatory and compliance aspects, a lot of things on my plate as a startup founder. Before starting Neura Health, I was working as an associate director at IQVIA, formerly called IMS Health. I was building machine learning products over there, responsible specifically for building the data layer for a ADA machine learning product that they were building And before that, I was at Capital One. I was transforming and migrating the direct bank's data warehouse to AWS cloud. So I have been working in data space for almost more than a decade now. My expertise has been in data, cloud, and machine learning technologies. Let's get to know a little bit of the domain that we are working at Neura Health. Now, it's around breast cancer. So breast cancer is a leading cause of cancer-related deaths worldwide. There have been more than 500,000 deaths due to breast cancer, and those numbers are from 2011. In US particularly, breast cancer is considered to be the second leading cancer-related cause of death for women. It's second only to skin cancer. So there are 40 million mammogram exams are conducted every year in US. And you'd be surprised to know that a woman is diagnosed with breast cancer every 3 minutes. And a woman dies of breast cancer every 13 minutes. So mammograms is considered to be the first step to screen for early detection of breast cancer. However, the false positive rate from mammography, it costs almost around $3 billion per year. In addition to all the anxiety that comes along with going through this early screening procedure for women. Another story, developing countries like India, there's just one radiologist for 100,000 people, whereas that ratio is 10 times higher in the US. 1 in every 2 Indian women with breast cancer, she does not survive. And only 66% live past 5 years of being diagnosed, compared to rates of around 90% here in US, Australia, and other Western countries. So we at Neura Health are building innovative AI products to address such problems and augment our radiologists in the early screening of breast cancer. So breast density is considered as one of the risk factors for breast cancer. And breast density is categorized across 4 classes. So we are building the AI classification model using deep learning. And the first product that we are coming up is called Neura Detect. It's built using deep learning or convolutional neural network. And it can detect breast density from mammography images, which is taken during initial screening for breast cancer. And it's able to detect breast density across all these 4 classes, class A, B, C, and D. Now, particularly, it's very difficult, even for like expert radiologists, to consistently distinguish between class B, which is the scattered density, and class C, which is heterogeneously dense from a mammogram exam. The AI model we use is designed to classify this with an accuracy comparable to an expert radiologist. So we see Neura Detect to be used, of course, by radiologists in the hospital setup or at an independent imaging facility. But it can also be available for remote locations where there are no trained breast imaging radiologists, or also to get as a second opinion in a direct-to-consumer model. And also in countries like India or in a continent like Africa that do not have enough radiologists to serve their population. So essentially, we are looking to increase productivity of radiologists in such developing countries by providing our tool to substantially increase the number of mammography images they could look at using AI and benefit the women population there. So from the technology stack point of view, Neura Detect is actually built to run on cloud. And we are using Google Cloud and all of its other services. So a user can upload mammography images directly to the Neura Health's web portal. And the breast density classification can be done in real time, within minutes. It's built on top of recently released Google Healthcare APIs. These are still in beta mode, but it helps, makes it very easy for a small startup team like ours to not worry about setting up any upfront healthcare IT infrastructure. The front end for the second opinion use case that we are building is built using React.js. The backend is all Firebase based. So that includes all the authentication, hosting the application, any storage requirement, any NoSQL database needs. And all the logic is built using cloud functions. We use Stripe APIs for payments. They are also in Firebase called Firestripe library that we use. And then the inference module is run on Kubernetes, and it's built using a Docker image that we built. So yeah, in a nutshell, this is how our machine learning pipeline looks like. So we take the data, it's a publicly available data set from the Cancer Imaging Archive, and it's highly curated and annotated by world-renowned radiologists like from Stanford. We pre-process that data, like cropping, for example, that needs to happen before feeding it to deep learning algorithm. And then we use Google AutoML to train, validate, and test the AI algorithms. Once the AI model is trained, as I said, a Docker image is created using Docker's. We use Google Container Registry, and then deploy it using Kubernetes Engine, again, from Google. Kubernetes Engine helps us with any scaling needs and making sure that any fluctuation in demand is accurately taken care of. This is the user and data workflow for the second opinion use case for NeuraDetect. Here, the user can interact with our web portal that's built using React.js and hosted by Firebase. The authentication is done using Google account by Firebase. User uploads 4 mammography images. That's all we need. That's all is taken during that exam, early screening of breast cancer exam. And upon those 5 images that we receive, we can give insight into the breast density. There is a breast imaging RADS, or called BI-RADS category. That categorization information, and then any signs of malignancy that might be there in those images, our AI model is able to predict that as well. These images go into Firebase storage. User is prompted to make payment, and then we, as I said earlier, we use Stripe for that. And once payment is done, those images are fed to the AI model, which runs as an inference module hosted in the Kubernetes engine. And then results are shared with user as a PDF report on the front end, where the user can download it for their personal use. Looking into other use case of the clinical workflow, this is would be in a hospital setting. And you can see it integrates seamlessly with the existing clinical workflow. This solution is conforming to DICOM standards. DICOM, it stands for Digital Imaging and Communication Standard in medicine. A typical clinical workflow might consist of a mammogram modality, a PACS server, and a radiology workstations for radiologists. So in this workflow, a DICOM router could send images directly from that modality to Neura Health's Google Cloud, where all the images are saved in Google's Health Store using healthcare APIs. And the inference will be done by the NeuraDetect engine and get that inference within minutes. And the generated breast density result is saved as one of the DICOM tags in a structured report format. And those results could again be fed back to the clinical workflow using that same DICOM router. So this is just a preview. I'm looking forward to sharing additional details about what else we are doing at Neura Health during my talk at the conference. And also looking forward to meet with all the attendees and presenters next month at the event. Thank you. And if there are any questions, I'll be happy to take them at the end. Thank you.
The Edge. My name is Franco Vieira, and this is a joint presentation with my colleague, Rafael Zotto. Quick introduction about ourselves. So for this talk, Rafael and I, we both work for HP Personal Systems Software. We used to work together in the data science team. Nowadays, we have a slightly different focus. I keep working with machine learning in data science focus, and Rafael is more focusing on developing new products and working on the innovation aspect of personal systems. A quick introduction about ourselves. And interestingly, we both live in Brazil. Here is where the presentation starts. So there are some topics in the industry where we need to define certain things before we move on, and edge computing is one of them. Here I'm going to talk about what edge computing means for personal systems, and then as you can see here, it means both the real edge devices, smart devices, for example, empowered with AI capabilities, or a near to the edge or on-prem solution empowering less powered devices to leverage machine learning services to build more richer experiences. In both cases, we have the same drivers here as defined on the screen. So we will discuss about the latency issues, bandwidth, some sort of a privacy, and limited autonomy for use cases focusing on edge computing. Next, we are going to talk about our motivators. As you know, HP is a company that manufactures personal computers, printers, 3D printers, all sorts of personal devices. And these personal devices and the device in general, they are composed by hardware and software. And ultimately, we are developing more richer experiences leveraging machine learning and trying to improve the experiences. And then as you can see on the screen here, most of the cases we have cyber physical experiences. For example, we have a printer, and then we want to, while we are printing a photo, for example, we are trying to analyze if the photo is okay, or we are building a 3D part, and then we need to check if the 3D part is fine and all the things are going well. So I need to run some machine learning models, inferences while we are producing the part. So it needs to be very fast. So that's the summary here. So we have to run AI use cases. We have to run machine learning inferences very fast to not prevent the real physical experience. So this is what we call the cyber physical experiences. And this is the main motivator to HP build its own edge stack for machine learning. After that, we'll go through to our edge stack architecture. As you can see here, so we have a multi-layer stack. We started doing development on top of our high-end machines, our workstations. So this is the device layer. After that, we have the OS layer, which is for us Linux, any kind of Linux. On top of this, we have Kubernetes and Docker containers. In a higher level, we have application services orchestrations, and then a connection of different clients to this backend, being in the device or near to the device, as I mentioned before. So this is what we're going to talk in the talk during the formal presentation. We're going to go in more details about what this edge stack is, what the architecture is, explore what open source we are using, what the custom objects we developed. So we are going to explore these things. Another aspect during the presentation is the exploration of the different targets. For example, certain use cases like retail use case or manufacturing use cases, they require more stronger machines like HP Z workstations, machines with lots of memory, lots of GPU power. In some cases, we have smaller and more constrained hardware scenarios, like, for example, a point of sales, a POS, and then where we have only a smaller GPU-enabled motherboard. We have Raspberry Pis, or we have Jetson Nanos, or very similar to these things, and then empowered with using TPUs instead of GPUs. So we are going to explore how HP tackle the solution for both scenarios, high-end, low-end, using the same architecture. And ultimately, also, we are going to explore how we are kind of enabling engineers to use their own notebooks to use the same platform to develop end-to-end before publish to a production environment. Next, during the development, we explored the different approaches, and one of these approaches that we found more promising is the serverless functions. So this is something that in the machine learning community is growing, especially if you're thinking about Kubernetes space. And then we have also, we're combining Kubernetes clusters deploying serverless functions on top of these clusters as we do for the cloud, because we believe this interchangeability, this interoperation between different environments, like promoting the same experience that you have in the cloud to the edge, is key for the success of machine learning at the edge solutions. So we are going to discuss the way we talked about the way we found to solve these problems using serverless functions at the edge, and how can we build customer applications on top of that, even considering latency issues, very low latency issues. For example, if you have a frictionless checkout solution like Amazon is doing, for example, you have to be very fast and very efficient in order to deliver a good experience for your customers. In the end, we're going to talk about real use cases. So this is one of the examples we're going to explore, but we have another ones related to smart manufacturing, retail, media, healthcare. And then we're going to explore how we are utilizing the previous resources, how we are applying the constructs promoted by the Edge stack to different machine learning pipelines. How do we compose services? How do we tackle the different challenges? For example, how can we increase the utilization of GPUs? How can we increase the efficiency of the smaller, harder to deliver good experiences? How can we create machine learning pipelines, and how can we deploy the machine learning pipelines on top of Kubernetes clusters? And then during this presentation, we're going to kind of promote both the architecture aspects of the solutions, but also the real implementation scenarios, and share with the audience. And that's it. So very hands-on, and I hope a useful experience for everyone.
Thank you, Franco. Can you all hear me?
With a quick questions, right, about how many people are data scientists, how many people are data engineers. So my principle today is it's how to make it simple, right? Because AI or machine learning, it's very complex. I'm a big supporter for democratization of AI, how to make it easier and accessible for more users. Topic agendas, we talk about AI, talk about machine learning definitions and set the level. And then we talk about some of the problems why a lot of people are still in a very early stage in exploring AI, and also some of the facts that I'm going to share, some numbers. And then I'm going to introduce different pathways, tools, platforms to implement AI in different ways. So my purpose of the presentation is to challenge the people who are doing AI today and to think differently, right? Maybe they can find a more effective path to achieve their business goals. And then I'm going to leave, hopefully I have like 10 or 15 minutes about Q&As. So I'm going to introduce about intelligence, talk about machine intelligence, human intelligence, and how do we set, kind of the metrics or benchmarks for measuring artificial intelligence, and all these, different sub areas, deep learning and predictive analytics, translations. I'm going to give examples on, some of them, and maybe a combining, an overall purpose of artificial intelligence. I'm going to talk about machine learning, so how you differentiate from, classical programming. Where classical programming, basically, you set the rules, you send the data, they will give you the answers.
Elliott, do you have any slides there, but we don't see it?
I'm sorry, you can't see my screen?
Do you have any slides?
Yes.
He's showing, Murthy.
Yeah, I can see the slides.
Ah, okay. I'm not able to see.
We are able to see.
Okay, good enough.
Oh, okay. So I'm sharing the slides. Hopefully everybody can see.
Yeah, we are able to see. Yeah. Go ahead.
All right. So yeah, classical programming, basically you set the rules, you send the data, and the program will tell you the answers. Right? So for machine learning, basically, you send the data, and you provide the labels, which is the answers for the machine learning. And then machine learning will figure out the rules, and you can use the rules to make predictions. I'm going to talk about deep learning. So different neurons. I'm going to use, very typical example. How does machine to identify cats or dogs, right? Different neurons to extract features from cats or dogs, different years, the overall shape, their hair colors, what kind of tail, and then to identify, okay, once you aggregate all the features and to say, okay, this 90% or 80% is a cat instead of a dog. And some of the problems did I hear someone have questions or? No? Okay. So I'm
No
going to talk about
questions, go ahead.
Yeah, so some of the problems in AI. So use case, what is the right business problems, right? That's very common in a lot of organizations. They want to do AI just because a lot of people do an AI, right? They don't understand what kind of problems AI can solve and how can AI bring real business values to their organizations. I'm going to talk about talents. Does AI have a lot of things involved, from data all the way to making predictions and scale integrations, IT, data scientists, data engineers. And it's more than ML, right? Making a model, it's only a small piece in the overall process. And development scale is also one of the biggest bottleneck for a lot of organizations. In the later on slides, I'm going to talk about the GPUs or even TPUs, how to accelerate in the infrastructure level, and also I'm going to talk about different ways to optimize the pipeline. So first start to identify what kind of problems are good for AI, right? So analytics, there are 4 different categories. So the 2 categories for descriptive or diagnostics, more like BI for reporting. So you can do like aggregating by SQL queries. And predictive or prescriptive, I'm going to give examples as well during the presentation. We'll talk about, okay, these problems will be best fit for AI or machine learning. Some shared effects, right? So only a small number of people who can really build machine learning models, who can implement AI in the organizations. But like I mentioned before, I'm a big supporter for democratization of AI. So the question is how to empower more users, right? So there are tools that are available in the market. And how do we choose? How do we compare each other? So the overall ML process, identify business problem, develop hypothesis. In the end, we can start, exploring data. So data has to have some relationship to the predictions and also to the AI problem that we're trying to solve. And then how do we find out what would be the best relationship or the best representation of the correlations between data and problem? That's how we build a model. And the last one was how to apply and scale, right? You only have one model, one node, it's easy, right? But what if you have 100 nodes and you have to have, different kinds of machine learning models, not just for training purposes, but also for serving the real business applications. How do you map to different GPUs? And how do you share memories? And those kind of questions that we need to ask. Okay, so here it shows, right, building a model, training a model, that sounds like a lot more in machine learning, but it's only a small piece, right? It's only like 2 steps and in between the process. The keys to successful ML, data, what data do you have? How many data do you have? Model is what algorithms can you use, right? There's TensorFlow, there's PyTorch, everybody knows. But what else can you accelerate your journey to ML? The last one is infrastructure. How do you optimize training and development? And more importantly, how many people have thought about the pipeline? Is it reusable? Is it scalable? Or can they bring it to different platforms? You can train one place and you can run anywhere. So what data to use there, I'm going to talk about different data types. The structured data is probably in some sort of table or schema format. And then there's time series data, IoT, images, videos, text documents, and the last one is the audio files. So for structured data, these kind of things you can do. I'm going to talk about classifications. I'm going to talk about recommendation, the collaborative filtering, those kind of mechanisms they can use. Anomaly detection, that's, a k-means So you don't have to do like supervised training. You can do unsupervised. So I'm going to give examples on those as well. On the unstructured image identification, there's object or information extraction. Is identify different styles or classification, put images into different categories. And the last one is the text-based, right? We can talk about call center log analysis, language identifications. So there are a lot of use case for different type of data. So before you think about the business problem you're trying to solve, you look back your data to see, okay, what data do I have, and what kind of things that I can do with the data with different ML algorithms. And how to build models, of course, is the ML framework. You can use TensorFlow or PyTorch, scikit-learn, those kind of frameworks you can use. You can build from scratch. It's fully customized and requires a lot of expertise for data scientists and data engineer. And also there's ML APIs you can use. There's API audios or text. You can send the data in. You don't have to build any models. You don't have to train anything, but you can use it as is, right? It will give you results on what's the object in the image or what's the summary in that text, but you cannot customize. And if you want something in the middle that's AutoML, so I'm going to show the concepts of the product. It's AutoML, it's pre-built models, and you can build your customized model on top of the generic model, right? So that's meet in the middle. It doesn't require much expertise, but you can really have a customized model in just a few hours. And I will show example of AutoML. For example, you can send images. Usually the image API will tell you what object is there, but you can send, for example, if there's millions of images, you can send 1,000 images for the image for the model to identify you instead of others. Okay, ML accelerators. I'm gonna kind of introduce the CPU versus GPU, and I'm going to talk about TPU as well, what's optimized in the vector matrix, the operations inside TPU pod, and how do you accelerate, and it's like times faster than the Volta. So I'm going to show some metrics as well in here. ML pipeline considerations. Instead of just building a pipeline for each individual use case, think about easy to use, run anywhere. How do you prototype? I'm sorry, just 1 second. Sorry about that, because my kid is sick, so I'm kind of staying home today with her. So think about, all these different considerations that normally people haven't thought about, but how do we achieve, a flexible pipeline that you can reuse, you can run anywhere. So here's a new pipeline design. I can talk about Kubeflow as something you can compose in one place and run and train anywhere else, right? So instead of you can have like different pipelines for different use case, you can think about what components you have and swap components and build up a one pipeline for, all different kinds of use cases. Yeah, that's it.
Thank you.
Okay, any feedback?
Any
I'm sorry about my voice.
Yeah, we'll wait for the question and answer. Audience, any questions from anybody?
Wait, sorry about that. It's my kid. No, just 1 second. 5 minutes. Okay. All right. 5 minutes. Sorry about that.
Elliott, we have a question saying what ML pipeline?
What ML pipeline?
Yeah, in terms of its structure.
Okay, so the pipeline is basic.